Continuing with section 5.6, the real zeros of a polynomial function, we have two more theorems. Every polynomial with real coefficients can be uniquely factored into a product of linear factors and or irreducible quadratic factors. So what does that mean? Linear factors, of course, means factors that have an x to the first power, like x minus 2 or x plus 1. Or irreducible quadratics are quadratics that would lead to non-real solutions. A polynomial function with real coefficients of odd degree has at least one real zero. So what that means is that if the power is third degree, fifth degree, seventh degree, you know you have at least one real zero because non-real zeros are in pairs, right? We have conjugate pairs. So if you have pairs, but then you have like to the seventh degree, then you know that one of them must be a real zero. Okay, find the real solutions of this equation. Of course, that's the same as finding the real zeros of a function. The maximum real solutions would be what? 4. That's our degree of the polynomial. Positive real solutions. Count the sign changes. Positive to negative, there's 1. Negative to positive, 2. Positive to negative, 3. Negative to negative, no change. So 3, or if we have a pair of non-reals, 1. Let's substitute in negative x, and remember that just changes the sign on the odd powers of x. So we have x to the 4th plus x cubed plus 2x squared plus 4x minus 8, counting the sign changes for negative real solutions. We just get what? 1. There's only one change. Okay, so we either have 3 positives and 1 negative for a total of 4, or 1 positive, 1 negative, and 2 non-reals for a total of 4. All right, P are the factors of negative 8, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Q are the factors of positive 1, plus or minus 1. P over Q will be the same as P, right? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All right, so we're looking for 3 positives. Let's maybe start with 1. Our coefficients are 1, negative 1, 2, negative 4, and negative 8. Bring down the first number. Multiply, add, multiply, add, multiply, add, multiply, add. So we get negative 10. 1 is not one of our real solutions. Let's go to 2. 1, negative 1, 2, negative 4, negative 8. Since I didn't find 1, I don't have a depressed equation. I'm still using the top line. Multiply, add, multiply, add, multiply, add, and multiply, add. And I find that 2 is a real solution. Now this is my depressed equation. These are the coefficients. It was x to the 4th, so I know now it's 1x cubed plus 1x squared plus 4x plus 4. There are 4 terms. I can try grouping. If it doesn't work, fine, I can go back to synthetic division. But if it does work, I'll get closer sooner. So let's factor the first 2 terms, x squared, x plus 1, and 4x plus 1. So grouping is going to work. X plus 1 times x squared plus 4 equals 0. Okay, so x plus 1 equals 0, x equals negative 1, x squared plus 4 equals 0, x squared equals negative 4. That's not real. Those solutions are not real. So I'm not going to continue with that because we're asked to find the real solutions. So our solution set, when we find solutions, we do have a particular notation. Our solution set included, what did we find? We found 2 and we found -1. Those are the real solutions. So we found 1 positive and 1 negative, and we found the 2 non-reals. Now they didn't ask us to factor this, but if we needed to factor it, here's what it would look like. We would have x minus 2, and it only occurred once, multiplicity 1. We would have x plus 1, and then we'd have an irreducible quadratic, x squared plus 4. It's irreducible because when I try to reduce it, I get non-reals. So this shows our theorem here that every polynomial function with real coefficients can be uniquely factored. These are the unique factors of it into a product of linear and this is an and situation, irreducible quadratic factors.